Good day and welcome to the Analytical Lounge, where we talk about technology, we talk about AI, mathematics, and other pertinent subjects that are relevant in this day and age. So today, I thought we should go over a very important topic, which I've entitled The Power of Choice. We determine the AI that we want. Because you find that with artificial intelligence and other sciences, basically like mathematics, physics, they've been presented to us in a dogmatic way, such that it's as if everything is written in stone. There's no room for creativity. So you take it or leave it. The way that AI has been presented to us is inevitable. It is what it is, and we just have to accept it as it is. And this is very important, especially for the global south countries that don't have the capital to be coming up with these big data centers, to be coming up with these foundational models, which require billions of dollars to be able to run. So what is it that we can do as there's a helicopter going on, today with the marches in South Africa. So there are going to be helicopters just flying up and down. So yeah, please pardon that sound. So you find that we are behind as Africa, as the global south, because we do not have our own foundational models. We rely on a few companies like Anthropic, like ChatGPT, that is OpenAI, and we are at their mercy because we don't have systems of our own, and we have to start where we are because this is where we are. But what is it that we have? What is it that we can use in order to be able to actually have a meaningful contribution to artificial intelligence? Because just like the previous technological revolutions, we have been left behind and have had no part to play and have been trying to catch up. And you find that we are still not there in terms of catching up. But given where we are, we can actually do something, right? So the talk that I'm going to have today, entitled The Power of Choice, we determine the AI that we want, is based on a book that I wrote entitled Mathematics of Disruption, a South African story about AI, fragility, and the power of math. So I use mathematics as a language to talk about the possible innovations and how we can actually use what we have. So it could be philosophy, it could be the problems that we have, it could be our own unique knowledge, African knowledge that we have. How can we use that and translate it into something valuable that the whole world can also consume? So I use mathematics because that's the language that I speak in natively. So that's why I chose to use mathematics as a vehicle to describe the phenomenon that I'm talking about. So please do feel free to post any questions. If you do have them, just put them in the chat, and I'll be able to respond accordingly. And yeah, so let's start, right? So if you've got any questions, like I said, drop them in the chat, and feel free to keep posting the questions. Then we'll go through them. Okay, so I'm going to put up my presentation so that you can also have a look at the deck that I prepared. Okay, so the power of choice. We determine the AI that we want. So you've had Sam Altman and them talk about the inevitability of AI, to say that we literally don't have a choice but to follow the trajectory that they have taken. And this is something that we didn't have control over because we were not in the rooms where the funders were deciding which technologies to fund, which algorithms to drop, which type of AI to pursue, because there were so many different approaches to AI that were there. Some were better than others, but the one that was chosen was the one that had the least path of resistance, which was fundable from a Silicon Valley type funding model based on scalability, but at the compromise of understanding, right? Understanding in the neuro sense, you know. So you find the two main schools of thoughts when it came to AI was the symbolic AI and the same ultimate AI, right? Which is the deep learning one, which was being modeled around neural networks in the brain. So you find that with deep learning, it was specifically correlation at scale, where it was good at pattern matching. And if it was fed with lots of data and with lots of compute, then it was exhibiting some form of intelligence. And that is what won the race, because it could be demonstrable to people that you can actually have a platform where you can talk to, and it can talk back to you, and it shows intelligence, and it can read a vast amount of data. That is the big corpus of data, which is like the size of the internet. So that is the difference between deep learning and the other side of things, where your Judea Pearl and them were talking about causal inference, causal AI, which was focusing on understanding, which is more symbolic AI. So some people like Gary Marcus from NYU, he talks about neurosymbolic, where it's a compromise between deep learning and causal inference, causal AI, where we can actually bring in causality, of which you find that the systems that we have, the current systems, they're improving exponentially on a daily basis, because we as the users are actually helping them learn through reinforcement learning, through human feedback. So whenever we give feedback on the outputs of the AI, it's learning recursively and improving. Very soon, it will be able to recursively run as agentic systems. I think that's what everybody's talking about when they're talking about loop engineering and stuff like that. But then I want to take you back on a journey to say we have this thing called the fallacy of inevitability, meaning that this thing to say it was inevitable for us to be where we are is a lie, because everything is determined by the decisions that were made by the venture capitalists, by the technology companies, and it was based on their schools of thoughts, their own a priori beliefs and motivations, right? So the dominant narrative treats today's AI as a fixed track laid down elsewhere. So they believe that bigger models, more GPUs, more compute, more data means that we are going to have better inference, right? Better outcomes. But I pose the question to say the human brain uses very little energy, but the output that it brings out in terms of intelligence is super amazing. So that means that it is possible to have a small model that can exponentially give amazing outputs. So it means where we are is a good start, but there should be ways that are sustainable, that will make sense for countries like African countries that are energy poor. That is, they're struggling with electricity, they're struggling with compute, with and lack of capital. So there should be a way for us to have some parsimonious approach to AI, such that we can also be able to compete with your Googles, to compete with your Anthropics and OpenAIs, without necessarily having to incur the costs that they have incurred, because it's becoming ridiculous. I mean, the amounts of money. I think you saw the trillionaire Elon Musk, right? Although he's merged his space company with the AI company Grok XAI, but we can't all be talking about trillions. So many people are being left out because they can't participate at the foundational level of AI. So they are subjected to the system prompts of your foundation models, which is not ideal from a sovereignty perspective and from a creativity and preservation of culture and norms across the world. So that is something that we need to make sure that we correct. So you find that when you hear somebody say where we are technologically, especially with regards to AI, is something that was inevitable and there's no way we can stop or change course, then you find that those people are benefiting from the current structure such that they're trying to give you the impression of inevitability. So that's important to note. So there's this sentence that was spoken by the AI in the mathematics of disruption. So this is the book that I showed you earlier on that I wrote. And this book has 4 characters. It is Tandiwe, who is a curious student, who asks a lot of questions in a Socratic manner. Then we've got Sipo, who is a pragmatic engineer, almost a skeptic of AI because he's in the field, he's been through machine learning, and has seen so many failed projects such that he's skeptical about AI. Then we've got Professor Kumalo, who is furnishing his wisdom and answers to the curious student Tandiwe and to Sipo, the skeptic. Then the 4th character is the AI, the machine. This is the one that's quoted in this particular slide, where this quote says, "Will you build me with wisdom, or will you let others build me for you?" So this is a question specifically to the people that are outside the bubble, the AI bubble of Silicon Valley and China, where these are the only people that are literally determining our future. So what is it that we can do to be part of the building process of this AI so that our voices, our aspirations, our norms, our culture, and everything that we can contribute is encoded at the foundation level, right? So that is important. So inevitability is the most disempowering story we tell about technology. The alternative is harder, just like causal AI is harder, because you are proving causality. You are pursuing proper understanding, right? Not just pattern matching at scale, but moving from correlation to causality, which is harder. But then if we don't do the hard things, then we are leaving a lot of value at the table, and we are losing opportunity to be able to build a sustainable technology that is explainable, because currently the deep learning methodology is a black box system that in as much as people understand the mechanisms of how generative AI is generating the next word, the next phrase, the next picture, but they don't understand the actual mechanism that is underlying the whole process, because it's based on deep learning, which has so many, given the parameters of AI, which are in the billions, it's not comprehensible to our own minds. So that means that we need systems where we can be able to explain that A caused B and B caused C, such that we can explain. Imagine applying for a loan at a bank, and then they use a black box system, and they tell you that no, we've rejected your loan, but they can't tell you why. So that kind of stuff is something that we are all experiencing en masse with the LLMs. But because there's a utility value to the LLMs, we ignore the fact that there's no explainability. So that is something that we actually need to work on as a collective. And we as Africans we need to dig deep into our own methodologies, our own philosophies like Ubuntu, to be able to also bring wisdom to the to the development of AI, right? So that's important. Now, support beats merit. So you find that in the history of technology, it's not the best technologies that have won, right? But it's those that were supported well, that had distribution, that had funding, that were on the correct political side of things at the time, that they became mainstream, and some better technologies were overshadowed. So I'm going to give you 3 examples. One with regards to the Edison versus Tesla war, where it was DC versus AC. You'll find that there was a battle of the technologies, right? Which electricity type to use, and you find that Edison was funded so much. He was politically correct. He had people in higher places, your JP Morgan and stuff like that. But Tesla didn't have. Fortunately for humanity, if it wasn't for the Niagara Falls water project, where they needed to harness the hydroelectric power, and Westinghouse came to the rescue of Tesla, we would still be stuck in the DC world, that is direct current, as opposed to the AC. So eventually, the best technology won, but we ran the risk of being in battery packs without big generation that can actually be used to power some of the technologies that we have currently. Then you look at the home video side of things. It was Sony versus Betamax, where Sony was actually better, and it lost to JVC, right? And that was with the discs as well. You find there JVC had distribution, and Sony lost out. Then with the keyboard, there's something called the Dvorak keyboard, which is actually better from an ergonomic perspective, but you find that it was never mainstream. In fact, the QWERTY keyboard is designed to make us slower typers. So it means in these 3 cases, it was a case of this technology versus this one, but a decision was made on our behalf, and that became mainstream. So that is where now we, even in the AI era, we have to use the same lens to say, okay, this is the status quo, this is what is, but what can be? And given where we are, our lack of capital, our lack of generation power in terms of electricity, the risk with the water usage that the data centers are using, what is it that we can do to build better systems that can better serve humanity? So that is a question that I'm posing today. That is a question that I spoke about a lot in the book, Mathematics of Disruption. Okay, so you'll find that sometimes just marketing is the difference. Like I said, in the Edison versus Tesla era, Edison had all the resources and he was better at marketing. He was more corporate than Tesla. And he literally did demonstrations, public demonstrations of executions to show how dangerous alternate current was. he was determined to make sure that AC would not see the light of day. But fortunately, it wasn't scalable, and that hydroelectric project that Westinghouse sponsored Tesla with was a proving point that changed the trajectory of technology. So that is important. That's an example. I'm not going to dwell too much on that example. And then the Betamax versus VHS, again, this is something that I spoke briefly about, where Sony's one had a sharper picture, it was better built, but VHS had what? Had distribution, and they managed to corner the market because I think they had a gaming partner that they partnered with, and they managed to corner the market and dominate. Same thing with HD, DVD versus Blu-ray. That was another disc war where, again, distribution and marketing determined whether the technology was going to win. Sorry. Right. So I'll not go into the keyboards again because we've already spoken about the Dvorak and the QWERTY keyboards. Now, I think the problem actually goes back to the way we are introduced to subjects like mathematics, where you are taught that 1 + 1 is equal to 2. It is a law that you shall obey, and that's it. But then they don't tell you that you can actually be creative within mathematics, right? Also, I think until you get to high school or something, or even varsity, you are confined to base 10, where 1 + 1 is equal to 2. But then if you were in binary, maybe 1 and 1 is 1, you know, or hexadecimal, or any other binary system, base system, right? So we are not told that there are alternatives out there, and you have the freedom to be able to be creative, to think in different bases, to even create your own methods, right? Because I remember when I was introduced to the axioms of arithmetic, where they talked about the distributiveness, associative properties, and to me they were law. And if anything breaks those laws of arithmetics, the axioms, you know, by definition, an axiom is a statement that is self-evident, so much that it doesn't need any proof, you know. So we were told that this is what it is, right? But then if you look at it, if you go back now to the development of AI, the development of technology in general, you'll see that there were compromises that were made that actually resulted in the associative law, right? Like the axiom of associativity, addition or multiplication was actually violated, but it was for expedience purposes. So you'll find that in the 80s, 70s, 80s, computer scientists realized that to make computers faster, they need to truncate some of the decimal points, right? So by losing some of the decimal points, they actually lost accuracy, so much that the numbers didn't exactly obey the axioms of mathematics. They were slightly off, but for the benefit of speed and computation, it was acceptable, right? So they cut out and maybe say a number like pi, right? 3.142, whatever. They just left maybe to 2 decimal places as opposed to going all the way, which is asymptotic anyway, right? So that was an executive decision that was made. But then the way that we were taught mathematics, we were taught to obey. in a dogmatic way, as opposed to saying, how can we play around with this mathematics to actually make it work for us, as long as we do not stray from accuracy too much, right? As long as it's in an acceptable range, right? So you find these are some of the orthodoxies that were in research, right, along the AI route, where in 1958, the perceptron, right, sparks early hope for learning machines, where that's where the different people that coined the term artificial intelligence at Dartmouth University, they were inspired by the brain, by the perceptron. And then there was some winter, AI winter. Then in 1969, there was an influential critic where that's where the first winter actually started. Yeah. So from 1958 to 1969, there was a lot of activity. There were papers around AI, but then there was a lot of critique on the practicality of the perceptron-based model. So it was frozen literally from 1968 to about 1986, where the likes of Jeff Hinton and others really kept the flame going, and they didn't give up on the perceptron-based model, which is neural networks and stuff like that, where you're literally mimicking how the human brain works, you know. So a handful of believers revived the idea with back propagation. So back propagation was that innovation that actually gave a lot of momentum for AI to come back, and it coincided with also the improvements in data compression. So that means that you could have faster compute, you could have more memory, so there were lots of things that came together in order for us to have the revolution that we're having now. So things had to happen, decisions had to be made for this AI to be where it is right now. And it wasn't inevitable. It could have gone another way, but it went the way it went because the funding, the support, the marketing was aligned with this trajectory that we have today. So that's important. So today's AI is a choice, not a destiny. The same contingency runs through the machines we use now, transformers, GPUs, gradient descent, and the race to scale are engineering decisions made under pressure, right? Because they are efficient, profitable, and entrenched. They are the status quo. They are the standardized methods that you don't have to go away from the well-trodden path, you know. So they are not laws of mathematics, right? And what is chosen can also be chosen differently. So I would recommend academics from Africa, from the global south, not to do research just to regurgitate the current suite of technologies, but to challenge it and bring in their own flavor that is actually relevant to the actual problems that we have. Because currently, if you look at it from a job creation, employment creation, Western world versus global south, you find that our problems are different. This version of AI is geared towards eliminating jobs or substituting jobs or reducing the amount of human activity in the workflows and stuff like that. Why? It works well for the West because they have a human resources crisis where their populations are getting old. They don't have enough young people that are coming up, and they don't have an unemployment problem. But in the global south, we have the opposite problem where we have unemployment. I mean, like I told you today in South Africa, there are marches going on by March and March. It's 30th of June, and they are marching uh, against illegal foreigners, and this stems around the idea of unemployment. So now, if we copy and paste the AI from the West, that is meant to augment or replace or substitute humans, then that means that we are exacerbating the unemployment problem instead of solving it. So that means that the AI for this global south should be fundamentally different, where it should be creating employment as opposed to reducing employment. So that is something that is so fundamental that we need to be able to think about it and be able to fashion and create our own way of owning the means of production. Because currently, like I said, we are subservient to Elon Musk, Sam Altman, Amodei, and Anthropic, because they are the ones that have the means of production, right? The same way that the land barons had the land during the feudal times, in the feudal system. So they are the new oligarchs, and we have to find ways to be relevant and to be heard. So it's important that we bring our own flavor in the research, and the research shouldn't just be geared to be put in a library or to be put in some journal. It should actually be useful such that it can be productized. Industry and academics should be working closer to solve uniquely African problems that Amodei and Altman don't necessarily have, and they're not motivated to solve because it's not in their purview. So that's important. So now, if you look at the innovation that I spoke about, where computer scientists literally played around with the decimal places, with the number of digits after the comma, for optimization in terms of speed and compute. So if you check now, what resulted was that a plus b inside the brackets plus c is no longer equal to a plus b plus c, which is the associative rule, because there is some inaccuracy, but it's acceptable inaccuracy, right? Where now they gain speed, but we abandoned the exactness of real numbers. So it means that our computer systems are no longer using the real numbers as we learned them in primary and high school. They are using a flavor of it, right? So this is what in the book I call the original sin of computing, whereby even if you put your model at temperature 0, where you're saying be as factual as possible, don't be too creative, don't hallucinate and all that, right? Even at 0, you'll find that if you had to run the same prompt, right, in Claude or ChatGPT 10 times, you're going to get 10 different outputs. They might be semantically equivalent, but they are different, right? And this is because of this floating point fragility that I mentioned, and also the fact that the allocation, the batching system during compute also affects where in the position of the neural net it is, also affects in terms of weights and stuff like that. So that means that you can never have a seeded answer where it's the same answer like we did with random number generation, where if you've got a seed, then you can replicate to the T, because we committed the original sin of computing, right? Then we move on to gradient descent. This is a method that um, people love in AI and machine learning, right? So again, you find that it's almost like you're blindfolded and then you're taking a step down a mountain, and at any given time, you are taking the best step at that moment until cumulatively you get the most optimal route, right? It's almost like guesswork. That means that you are going in blind, literally. It's not the most efficient algorithm out there, right? I remember the first time I met gradient descent was in a numerical methods class in a first year university. Yeah, I remember it very well. Right. So it means that these are methods that were chosen because of their ease of use, because they're incumbents, because of expedience, and because of the utility gains associated with using them, right? They were not chosen because they're the best, but they were chosen because somebody made that executive decision on our behalf, right? So to even go further, right, you find Elon Musk, right, with Tesla and XAI, has even gone further and said, you know what? Instead of cutting out the number of decimal places with the floating points, I'm going to remove all the decimal places and just use integers. So he's using integer arithmetic now, and he is actually solving for the for compute, right? Where from an energy perspective, he's solving for speed. He's solving for and because it's more parsimonious when you're working with integers as opposed to real numbers that have decimal places, right? So that means that he has the creative confidence to be able to say, I'm going to cut out the zero because I'm Elon Musk, I'm a trillionaire, right? Or I was a trillionaire for a day or two, right? Therefore, I can do what I want. So that's the kind of confidence that our practitioners and our researchers need to also have so that they can actually solve our problems. Because I bet you now his models are performing quite well, right? They are faster, they're using less electricity, but obviously there's a compromise where on accuracy, right? But who says that everything needs accuracy to the ninth decimal place or the 100th decimal place? So that is an executive decision that Elon Musk took, that you and I can also, in our daily work, we can also choose how we interact with AI and how we use our knowledge in that is from our daily living within the continent to be able to solve real problems, right? So that is a practical example of Elon Musk using his creative confidence to solve a real problem by using integer arithmetic. I actually wrote an article about it on Analytica. It says that I'll look for the link and I can share afterwards. Right. So you find that what we have is that there are things that we think are written in stone and we treat them as such, right? And it's important that we look for alternative methods. So let's look at some of these. So the first one that I spoke about was the floating point fragility, where it was the original sin of computing, where for expedience purposes, to gain speed, we played around with the floating points until it didn't obey the axioms of mathematics, of arithmetic. So we can use something called posit arithmetic, right? And low power computation. So this is something that African mathematicians, African researchers could be looking at how Africans can benefit from posit arithmetic, right? How can we benefit from that? Then on the algorithm, the one that I mentioned, coming down a mountain with a blindfold, gradient descent, where it's a trial and error, of which we know trial and error, that's exploration by nature, and is not necessarily the most efficient way, because you are being expansive in order to discover, and so that's the problem. So you could use second order methods and convex reformulation, right? So those of you who've done a bit of numerical methods, you'll know that there are different algorithms that can be utilized, like the Runge-Kutta. There's so many of them, right? So we could use second order methods and convex reformulation to actually get better and more efficient models than the guesswork that we have with gradient descent. Then, because deep learning was scalable and it was good at pattern matching and it was sellable to the investors, but the problem was that it was a system that is based on correlation at scale, right? So all it does is it pattern matches, it can predict, right? That's why you find the LLMs can predict the next word, can predict the next sentence, can predict the next overlay in a picture and stuff like that. That is just pattern matching and prediction based on the corpus of data that it read, or the whole internet and everything else that we provided. So we could look at causal inference. Causal inference, if we understand the reasoning about interventions, about counterfactuals, about the data generating process, like Judea Pearl likes to say, if we understand the data generating process, then we will not become victims of curve fitting, right? Because correlation is basically curve fitting, right? Then bloated memory models that memorize. That's why NVIDIA is $1 trillion company, because the models are bloated and you want more and more GPUs, more memory, more compute, more water, more electricity, more, right? Of which we could look at how can we use compression and MDL, right? And edge computing and stuff like that, that we can run locally on our phones. I know a few people that are looking at this on the continent because they've actually realized that we don't have the capacity to build these big data centers to be able to service our needs as Africans. So we're looking into edge computing. Then looking at brittle and flattened representations, right? So this is where almost taking surfaces, for example, let's say the surface where the gradient descent was, and flattening it using, because by nature of using correlation, that means that we're using linear models when we could be using nonlinear models, because not everything is linear, you know? So we could use, make use of geometry and topology so that at least we can cover all the different modalities, right? Where if you look at it, for example, like a phenomenon in mathematics now is relatively new called fractals. Fractals are everywhere in Africa. If you look at the Ndebele art, right? The Egyptian art, it's got lots of geometry, lots of expression. And we should be seeing that in our mathematics. We should be seeing that in our technology. We should be seeing that in our thinking. So we cannot be forced to use brittle and flattened representations that were shoved down our throats from the Western world. So it's important that as Africans, we have the creative confidence to bring ourselves into the academia and not just regurgitate what is being that is the status quo that is already there, you know. So I'm going to move to the next one. So disruption lies in the math, not the hardware. So that's exactly the examples that I've just given you in the last slide, where we're talking about how we can use mathematics to actually innovate, like what Elon Musk did to make sure that his uh, his robotics with Tesla, his spacecrafts with SpaceX, and also XAI are faster and use less electricity because they cut out the decimal places and use the integers, right? So we should have a situation where, if we're using edge computing, for example, right, low latency stuff, where a startup in Kailicha could train models as efficiently as Google, because we know that we should accept where we are, where we cannot outspend Silicon Valley. They have the money, they have the capital, we don't, right? So a single breakthrough in optimization or compression rewrites the economics of AI overnight. And that breakthrough is mathematical, right? It's an idea and it's available to everybody as long as you're doing math or math literacy. And by the way, don't limit my discussion to mathematics, because I told you that I'm just using mathematics as a vehicle to explain what I'm explaining. But you could explain it from your point of view. If you're a philosopher, if you're an economist, accountant, and you could also attack the same problems from your perspective, and cumulatively, as a collective consciousness, we can actually have something that makes sense, that is multidisciplinary, right? So compute is rented and fleeting. So chips age, prices shift, vendors change, right? Today, OpenAI is the best. Tomorrow, Claude is the best. Tomorrow, NVIDIA. Tomorrow, DeepSeek. What about, that kind of thing? So, but if the fundamentals, the mathematics of it, the thinking, the data generating process, and the underlying logic is robust, then you can actually ride the wave of these technological ups and downs and changes and stuff like that. So mathematics is permanent, right? In as much as you can be creative with it, but the fundamentals of it are as constant as can be, right? And then elegance outscales brute force. So this Silicon Valley growth mentality is good, but it is brute force based. But you could actually do it elegantly, parsimoniously, like I said. Right. Then, one thing that we have to realize is that the moment we own the means of production, the moment we own the ethos behind the technology itself, the moment we own the thinking and the philosophy behind the technology, then we're sovereign, right? So in this case, with the vehicle I'm using, mathematical sovereignty is sovereignty, right? Those who understand the foundations of AI can shape its future. Those who only consume, because we've been consumers of technology from the first industrial revolution, we've been waiting for the West to innovate, and then we become super users and resellers, as opposed to being at the core face of the foundation of these technologies, right? So South Africa, but because remember I wrote this book, South Africa specific, but it applies to the global South, already holds the ingredients to choose the first path. So you find that the problems that we have, right, are actually a blessing, because you find doctors here have got access to a lot of patients that have diseases that you can never get in the West, right? So that exposure to some of these problems is an opportunity to come up with solutions that the West could never come up with, So we've got world-class universities already. We've got urgent and real problems. We've got a young population, something that is unique to the global South. We even have satellites like the SKA that is in the Northern Cape here in South Africa. We have so many languages across Africa. Just in South Africa, I think there are 11 official languages. And the fact that there's plurality like that is an opportunity to actually create language sovereignty, And then obviously We have Ubuntu values, where you find in South Africa they call it Ubuntu, in Zimbabwe they call it Hunu. It's the same thing that you find across the continent, and it's something that grounds us. So it means that our design should be informed by this element of Ubuntu as a process. So that is something that we need to value, right? So these are some of the things that we should also look at that are not necessarily that do not necessarily fit into the Silicon Valley model of funding. Things like collective benefit over profit, right? Where we're saying AI for community health, not shareholder value. Transparency and explainability. I think I've explained that one, and I even used an example of a loan. If you apply for a loan, they should be able to explain why you couldn't get the loan. That's why you find banks, I think to this day, still use things, basic algorithms like binary logistic regression, because if they use anything more complicated than that, like deep learning, then they won't be able to explain. And that is something that they can actually be sued for, because you should be able to explain why you said no to that loan application. And then inclusivity. Uh, you should serve all languages across the continent, across the global south. And it should not just be for rich people, it should be for all incomes in all regions. And then dignity, technology that empowers people rather than replacing them. I think I've spoken about that our problem is different from the West, and we need to be creating employment, not replacing employment. And then obviously sustainability, to make sure that whatever we do is in concert with the environment, with our and making sure that we have a sustainable future for future generations as well. So that is something that we have to be cognizant of, and that is something that is uniquely African, right? So the choice before us, the future of AI need not be written elsewhere. We have the minds, the problems, and the values. What remains is the will and the choice. So whether you're a student, government, in industry, civil society, you have a part to play. And if you're a student and you're studying mathematics, then don't just do for the sake of getting the certificate, getting the degree. Do things that are meaningful and do the hard things, right? That solve real problems, not symptoms of problems. And then with governments, fund the foundations that are looking into explainability, fairness, fund the entrepreneurs and the students that are working in the field, right? And create an environment conducive for creativity, innovation, and growth. And then industry, because industry now, you find the problem with industries that, especially South African industries, that they'll tell you that we're judged on a quarterly basis. So something like R&D is a swear word, because it's long term and you might not necessarily see the results right there. So they want quick results. So in the end, they do things, the easy things. That is, they just go and adopt one of the OEMs, and they resell or become a middleman and stuff like that, of which that is not good enough. We need to be able to take from the dividends as well, right? And plow a good 30% of net profit after tax into R&D, so that we can be future proofed. That is it. And you find over time, it's actually good for the business. It's actually good for the shareholder values that you talk about. And then civil society, the watchdog, and the one that should demand transparency and hold AI accountability to the different stakeholders. So the question is, will you build me, that's the AI speaking, will you build me with wisdom, or let others build me for you? So thank you very much. That is my presentation for the day. and I hope that it was beneficial and really good. So thank you to Kashni, my classmate. We are doing a PhD together. So, so thank you. And I know that Kashni, your topic is very meaningful. It speaks to a lot of elements about localization um, and us owning the means of production. So all the best. See you tomorrow in class. Then I see Eckert is here. Thank you, Eckert. Always there to support. I really appreciate your presence. And yeah, let's keep pushing, and hopefully we'll be able to inspire and influence more people to be able to understand that we don't have to follow the script that the West has written for us. We can write our own script, and we should have the confidence to be able to do that, because we have everything that we need in order to do that. And then I see Ian is here. Oh, Pastor Ian, how are you doing? Thank you very much for joining, Ian. Thank you, and I really, really, really appreciate your comments. You say thank you, Ezai, for this informative talk. Indeed, consensus is not correctness. Yes, that is so true. So we need your perspective, Ian, to be able to um, to have a variety of views and be able to have meaningful change. So thank you very much to everybody for coming through. I know some of you were on Facebook, LinkedIn, YouTube, Twitch, and or Instagram. So thank you very much for watching, and please continue the chats. I will be engaging in the various chats even after the live stream. So thank you, appreciate you, and have a blessed day. Thank you.